real and virtual.
So we'll see that.
Depends on mirror.
Yes, some mirror will only form virtual, spherical. Okay. In case of lens, also some will only form virtual, and a particular lens like convex will form both virtual and real. Okay. Likewise, concave mirror will form both virtual and real, and of different sizes. So we'll see that.
Sir, there are 6 cases in concave mirror, but in one only the real image is formed.
So many real images in concave. 5 real, only one virtual. Yes. So you said opposite. 1 virtual, 5 real. And for convex mirror, only virtual. So we'll see that. So we are going to do that only. But first, this basics is important because we are going to use these terms again and again. Only thing to be understood is this. Different types of mirror. Rest is just ray diagrams. So do you have any questions here? If not, we'll take it while we are discussing the topics. Okay? Clear? Okay, everyone? So next is we are going to discuss image formation by spherical mirrors. So first let us understand what are spherical mirrors. So spherical mirrors are made from a hollow glass sphere. This is a hollow glass sphere. Okay. So obviously it will have a center. That center is marked as C. Now you make a cut on both sides. Okay, and then silver coat on one side. Here also is silver coat. So what you'll get is 2 bowls kind of a thing, like a spoon. Spoon is oval. Imagine a spherical spoon. Okay. So this will be one part, and this will be another part. Okay. So here the reflecting side, one is reflecting side, other one is silver coated. So the mirror where the reflecting side is bulging out, that is called convex mirror. So here the reflecting side, yes, bulges out. And this kind of a mirror is called concave mirror. Here the reflecting side is curved inwards, okay, like a spoon. So the base of the spoon is convex and the front of the spoon is concave. Okay. So in this case, this is concave mirror. So the reflecting side is curved or bent inwards. Okay. So generally mirrors are drawn like this. So then you have this. This is convex mirror, and this is your. This diagram is shown to tell you how the mirrors are obtained. Okay, so from the hollow glass sphere. So every sphere will have a center, right? So now we'll learn some terms associated with mirrors. So in the ray diagrams, all these terms will be used. So some terms associated with spherical mirrors. So first is C, center of curvature. Its symbol is C. So what is center of curvature? It is the center of the hollow glass sphere from which the mirrors are obtained, of which the mirrors are part of or obtained. It is the center of glass sphere of which the mirrors are part of. Okay. Then you have center of the mirror itself. This is called as pole. Okay. The second thing you will come across is pole, and its symbol is P. It is the geometric center of the mirror. Spherical mirror. Understood? So this point lies on the mirror. C does not lie on the mirror. Okay. Then you have what is called as principal axis.
Is the line passing through?
So it is a line passing through center of curvature and pole. So this line. So it is a straight line passing through it is a line passing through C and B. Whenever I say C, you have to understand it is center of curvature. B is pole. Okay. Fourth. What is fourth?
Focus.
Okay. So focus is denoted as F. What is focus?
So the point between C and P.
Midpoint.
Midpoint of C and P.
Okay. It is the midpoint of C and P. What is the significance of this point? So all the rays which are incident parallel to principal axis after reflection will pass through focus. Okay, you can see that. So it is at the midpoint between C and P. All the rays incident parallel to principal axis okay. So where is this focus? It is a point on the principal axis. Okay. Line joining CP is the principal axis. So focus is the point on the principal axis. All rays incident parallel to principal axis converge at focus. reflection. Okay, this is only true for concave mirror. Whereas if the rays are coming here, in case of convex mirror, it will be reflected like this. So when they are extended backward, then it will come here. Okay? So it will become clear when I draw the diagram. So it is at the midpoint between C and P. All rays incident parallel to principal axis converge at focus after reflection, or appear to diverge from focus after reflection. So there are two cases. First case is for concave mirror, second case is for convex mirror. देखो concave mirror में क्या होगा? So if you have a concave mirror, this is how you'll make the ray diagram for reflection by concave mirror. You make C and P. So if you have rays traveling parallel to principal axis, right? So at this point, what is the normal? What is the normal at this point? Curved surface normal is tangent is normal or radius is normal? Radius. So what is the radius? Line joining point of incidence with C. Once you have this, so you got the angle of incidence. So you can draw the angle of this measure, that will become the reflected ray. When you draw the reflected ray, you will find that it exactly cuts between the midpoint of C and P. Understood? Likewise, if you have another ray below the principal axis but parallel to the principal axis. Again, for this, what is the normal? C and point of incidence. Again, you can now draw the reflected ray and find that it crosses this point. So this point, where the parallel ray incident to rays parallel to principal axis, these are incident rays. After reflection, where it is passing? It is passing at a point midway between C and P. And that point is called focus or focal point. Okay? What if it was a convex mirror? Now, what is the situation for convex mirror? For convex mirror, C is behind the mirror. For concave mirror, C is in front of the mirror. Okay, the reflecting side is always front. Reflecting side is front, and the silver coated side is behind. So for convex mirror, C is behind the mirror. So focus also will be behind the mirror. So now take the incident rays here. This is parallel. So what is the normal? Normal will be this. Okay. So once you have the normal, you have to extend the normal on the reflecting side, because reflection will take place only on the reflecting side, not behind. You got it? So now once you have normal, now you can draw the reflected ray. So this is the reflected ray. Here also the reflected ray will be this way, right? So now when you extend it backward, you will find this will also come. Angle made is bigger. You will find that this also comes. So this is the reflected. Okay, so this is P and this is M. Now read this statement. It is at the midpoint between C and P, right? That is true. all rays incident parallel to principal axis converge at focus. So this is the case for concave mirror. Concave mirror mein everything converges. Now they are physically intersecting after reflection, right? So what kind of image it will be? Real image. बताया था ना real image में क्या होता है? After reflection the rays intersect each other. So this is where real image is forming. This case में क्या हो रहा है? After reflection the rays are diverging. So when you extend them backward, तो ये it appears to diverge from here. So this is now virtual image. Okay? But what is happening after reflection? All appear to diverge from focus after reflection. So these rays are coming from here. You got it? For proper diagram, you can see the book. This is slightly like it should be straight. Okay? So since I am drawing freehand, it's not coming proper. But you can look for diagram in the book for focus explanation. So the second part of the statement is true for convex mirror. Is that clear? So this is focus. Then you have fifth point, which is focal length. F. So what is focal length? Focal length is this distance, PF. ये वाला distance. So this is called F. यहाँ पे भी this is PF. ये वाला distance. So it is the distance of focus from pole. That is FP or PF. Distance is always measured from pole. And what is the symbol for focal length? Small f. Okay? So for both, you have focal length. Their signs are different. We'll discuss about sign convention little later. Okay. Similarly, we have radius of curvature. And its symbol is R. So what is radius of curvature? This distance. This is R. Likewise, this distance is F. So since F is midpoint of CP, so F must be half of R. Okay. So it is the distance of center of curvature from pole. That is EC. This distance. So for this distance, the symbol is R. Okay. So what is the relation between F and R? F is equal to R by D. Okay. And the last thing is aperture. So all these terms are associated with spherical mirror and also lenses. Same thing is applicable for lenses also. So once learned here, you don't have to learn it separately. Little bit difference is there. We'll only see the difference. Then we have aperture. What is aperture? This distance. Can you see this straight? MN. So when you have the spoon, or let's say you have a bowl, right? So you'll have the brim, right? The circular edge. So aperture is the diameter of the circular edge. You got it? So that is aperture. It is the diameter of the
Sir means it will be the double of C distance between C and P.
double of.
C distance between C and P.
No. It's not at F. It's here. It is diameter of the circular edge of the mirror. See, when you keep the mirror on a plane surface, then you can draw a circle. It is diameter of that. Okay.
The distance between M and N.
Yes, this one. MN. Straight line, MN. That is the aperture.
But the diameter passes through the center.
So this is the confusion. This is the diameter of the sphere. We are not talking about the diameter of the full sphere. Now from the sphere we have cut the mirror. This now mirror is separate. So how will this mirror appear to you? It will have a
We
circular.
can say it is its length of the mirror.
In 3D space, how it will look like? Like a bowl. It will have a brim. This is circular. This surface is circular. This surface. So the diameter of this surface. Okay. So it is the area through which the incident light is entering the mirror. Aperture decides how much light can reach the mirror. You cannot have more light than this circular cross section. Understood? So aperture controls the amount of light that can expose the mirror. Understood? So that is MN. MN. It is not diameter of the sphere. It is the diameter of the edge of the mirror. Okay? So this is all about the terminologies related to mirror. Now we'll see
That is
the
one
image formation.
principal focus.
This is the focus is also called as principal focus or focal point. F is principal focus or focal point. There are two more terms for this. Either it is just referred to as focus or principal focus. Because it lies on the principal axis, no? That point. That's all. So you may just write for focus as principal focus or focal point. Just focus. So three terms are used for the same thing. But the symbol is M. Have you written the first column? These are converse. Also called or principal focus. Or focal point. focus, principal focus, or focal point. Done? So everybody is written the first column. All these are just the basics. You will require all this to understand the further things. So questions will come from what we are going to discuss now. This is just the basics, without which you cannot understand what we discuss now. What I have seen is, although it has been discussed in class 6, the fundas of many students are not clear. So what is to be kept in mind? F is always in the middle of C and P. In all ray diagrams that you have to keep this in mind. So all your diagrams should appear logical.
Sir, is there any perfect?
Yeah, it can be derived also. Derived also.
Is there any fixed measurement for distance between P and F?
Yes. So if you have, like when you are making the spherical mirror with the help of compass, so that will give you say 6 centimeter. And obviously F will be at 3 centimeter.
Half of the.
Half of it, yes. That result can be proved. F is equal to R by 2. Because whenever you are drawing the circle, you know the radius. So F will be at R. Okay, can I erase this side?
Yes, sir.
Yes, any? If you have difficulty reading, please ask. I'll read it for you. So this we already know. So which two rays to consider for image formation? I told you for image formation you require minimum two rays. Yeah, so there are so many rays, incident rays which are possible. So what is the first point? Ray incident parallel to principal. Achha, are you done writing? Or still writing? Okay, right.
Sir, as per told in school, our physics teacher told that this book, the line, the single rule book, if we join 5 lines of it, the minimum length is 8.8 millimeters. So we have to take focus 2 centimeters and the center of curvature at 4 centimeters.
You just use the compass and do that. I mean that you are sure. You can actually measure the radius on the scale. And you will see the center of, you already know the center of curvature. Then focus is out, that's more easier. This method is manipulative. How do you know? Like you have to see it by experience and what curvature gives you focus where. But compass thing is straightforward. Once you know the radius, focus is half of it. Generally keep the radius as 6 centimeter. So focus will be at 3 centimeter for all diagrams. That is good enough. So do you understand this statement? So ray which is incident parallel either passes through focus or goes away from focus. Okay, so that's the first point that you already know. Second point, the reverse is also true. So the ray which is incident along focus, like this, after reflection it becomes parallel. So this is after reflection, after reflection. So we are just trying to discuss the nature. Also, incident ray along focus becomes parallel to principal axis after reflection. Correct? So this is opposite of first. Therefore, instead of this, if the ray was incident like this along the focus, it will become parallel. Okay? Same thing, just the direction change. Here also, if the ray was incident along focus, after reflection it will go parallel to principal axis. So second point is opposite of first. Nothing different. Third. if the ray is incident along center of curvature, okay, if the ray is incident along center of curvature, so center of curvature to any point on the mirror is nothing but radius. Okay, that means ray is incident along the normal. So what should be the reflected ray? What is the angle of incidence for ray along the normal? Zero. So it will retrace the same path because reflected ray also will be zero. So any ray which is coming towards C after reflection will retrace the path because it is normal. And for normal, the angle of incidence is zero. And by law of reflection, if I is zero, R also has to be zero. So it will retrace the path. So any ray, so ray incident along C will retrace the path after reflection. Okay. What is the fourth? So you can have ray incident at pole. So what should happen to that? When the ray is incident at pole, what should happen? So what is the normal at P? CP, isn't it? So whatever is the angle above the principal axis, the reflected ray will be angle below the principal axis. Correct? Because CP is nothing but normal only. Any line joining C to the mirror is radius. Okay. So ray incident along P is reflected below the principal axis. As per law of reflection. ठीक है ना? So there are these four different incident rays possible. इसमें से कोई भी दो रे लेके हमको डायग्राम बना. तो अभी जो भी हम इमेज फॉर्मेशन सीखने वाले हैं.
So मतलब इनमें से
कोई भी दो.
2, 1, 4 में से कोई भी
वन तो सब डायग्राम में है ही. ये वाला तो हर एक है. रिमेनिंग 3 में से जो कन्वीनियंट है उसमें से कोई भी एक ले. वो भी तुमको समझेगा. ठीक है? ये समझ आ गया. ये तो हर एक रे डायग्राम में ये वाला तो आएगा. एक रे हमारी पैरेलल रे प्रिंसिपल एक्सिस. बाकी 3 में से कोई भी एक रे. ठीक है? तो ये समझ के अभी हम डायग्राम बनाएंगे तो एकदम क्लियर हो जाएगा. तो बचेगा ही. ये मिटा दो दोनों.
यस सर.
दोनों कॉलम लिख लिया सबने? अच्छा लिखो. फटाफट लिखो नहीं तो फिर रे डायग्राम रह जाएगा. अभी ये वाली चीजें बहुत डिटेल में समझाते नहीं है. सीधे रे डायग्राम प्रैक्टिस कराना शुरू कर दो तो समझते हैं. पहले ये सब क्लियर होना चाहिए तो वही तुमको रे डायग्राम इजीली समझ जाएगा. समझने वाला पार्ट यही है. ठीक है. as far as possible use freehand diagram, don't use scale and all, use time. Okay, पहले practice कर लो फिर एग्जाम में बनाना स्केल. Middle, can I erase the middle column? So now image formation by concave mirror. ठीक है. So अभी हम we will keep object at in front of the mirror, है ना, at different positions, and then we'll have to see what is the nature of image form. तो image form के लिए हमको तीन चीज बताना है. तो कहाँ पे फॉर्म हो रहा है, पोजीशन, उसका साइज एंड इट्स नेचर, रियल है कि वर्चुअल. ठीक है. तो सबसे पहला ऑब्जेक्ट पोजीशन है ऑब्जेक्ट एट इंफिनिटी. फर्स्ट इज when object is object at infinity. इंफिनिटी का मतलब क्या होगा, फार फार. When object is far far, very far, very far. जैसे सन इज अ वेरी फार अवे ऑब्जेक्ट. ठीक है. तो अगर हम सन की तरफ मिरर दिखाएंगे और किसी को आंख में चमकाते हैं, ठीक है, सन को ऐसे लेके हम रिफ्लेक्ट करते हैं, तो आंख में तुम्हारे सन की इमेज होती है. दैट्स व्हाई यू गो ब्लाइंड. ठीक है. सो whenever the object is very far away, so only parallel rays are incident from a very far away object. क्योंकि तुम सन को देखो तो सन तुमको एक ही लाइन में दिखता है. दैट मींस सन से जो रेज आ रही है पैरेलल आ रही है. ठीक है. सो सबसे पहला डायग्राम तुम्हारा कैसा बनेगा, देखो स्टेप्स इन मेकिंग द डायग्राम. फर्स्ट यू मेक द मिरर. सो यू कैन यूज द कंपास टू मेक द मिरर. सो वंस यू use the compass, then you already will have C. फिर C और इसको ज्वाइन कर दो P. तुम्हारे पास C हो गया, तुम्हारे पास P हो गया. ठीक है. That radius is already known to you. समझो वो 6 सेंटीमीटर था तो 3 सेंटीमीटर पे मार्क कर दो. मार्क करके छोड़ दो, अभी F लिखोगे. ठीक है. Complete the labeling in the end. So when the object is at infinity, I told you only parallel rays are possible. So which ray is this? Ray incident parallel to principal axis, passes either through or away from focus. So in this case, will it be through focus or away? Through focus, because it is concave, है ना? Concave में क्या होगा? तुम्हारा ये normal है, तो reflected ray यहाँ से through focus. ठीक है? अगर ये कॉन्वेक्स मिरर होता तो ये अवे फ्रॉम फोकस जाता. समझ में आया? अब ये थ्रू फोकस होगा. ठीक है. तो हमने बोला इमेज के लिए हमको मिनिमम कितने रेस चाहिए, 2 रेस चाहिए. तो और एक रे भी पैरेलल ही होगा. तो एक रे हमने प्रिंसिपल एक्सिस के ऊपर ले लिया, दूसरा नीचे से ले लिया. तो इस केस में हमारे पास और कोई रे पॉसिबल नहीं है. इस केस में सिर्फ यही रे होगा. ये भी कहां से जाएगा, फोकस से जाएगा. अभी ये लाइंस कट होती ना, तो अगर तुमने अल्फाबेट लिखा होता तो उसके ऊपर से जाता है. इसके लिए अब जो अवेलेबल स्पेस है वहां पे एफ लिखो, क्योंकि उनको पता है एफ से ही जाएगा रिफ्लेक्ट होने के बाद. ये रूल है. लिख लिया तुमने सारा. तो ये फर्स्ट इमेज हो गया है ना. अब इसमें हमको क्या लिखना है, व्हाट इज द इमेज पोजीशन. So when the object is at infinity, the image formed by concave mirror is image is at focus. The image at f लिखते हैं. f मतलब क्या हो गया?
Size of the image, point size.
अब size is
Point size diminished.
highly diminished or diminished to a point. Size is highly diminished. ठीक है, और diminished to a point. दोनों में से कुछ भी एक लिख तो चलेगा. To a point. है ना? अब इतना छोटा सा रिफ्लेक्टिंग सरफेस है, इससे भी तुम सन को किसी की आंख में कर सकते हो. मतलब इमेज सन तो कितना बड़ा है, और उसकी इमेज कितनी रहती है? वेरी स्मॉल. ठीक है, साइज इज हाईली डिमिनिश्ड और डिमिनिश्ड टू अ पॉइंट. अब नेचर ऑफ इमेज क्या बनेगा? व्हाट इज नेचर ऑफ इमेज? व्हाट इज हैपनिंग टू द रिफ्लेक्टेड रे? आर दे इंटरसेक्टिंग? तो नेचर ऑफ इमेज क्या बनेगा? रियल एंड इन्वर्टेड. जब भी रियल इमेज है वो हमेशा कैसी होगी? इन्वर्टेड. दोनों साथ में लिखना. नेचर ऑफ इमेजेस रियल एंड इन्वर्टेड. इसको कंप्लीट कर दो. ये मिटाओ, ये साइड का. एक केस और कर सकते हैं हम रिमेनिंग टाइम में. अब देखो, हमारा पहले क्या था? ऑब्जेक्ट वाज एट इंफिनिटी. तो नेक्स्ट केस में क्या होगा? ऑब्जेक्ट हमारा मिरर के पास आएगा. ठीक है, तो पास मतलब बियॉन्ड सी. यहाँ पे कितने केस बनेंगे इसमें? 6 केसेस बनेंगे. पहला केस क्या था? इंफिनिटी. बाद में हमेशा डिस्टेंस हम मिरर से लेते हैं, तो मिरर से देखेंगे तो बाद में बियॉन्ड सी, फिर एट सी थर्ड वाला, बिटवीन सी एंड एफ फोर्थ वाला, एट एफ फिफ्थ वाला, बिटवीन एफ एंड बी सिक्स्थ वाला. तो याद भी नहीं करना, मतलब लॉजिकली यू कैन, एक डायग्राम तुमको समझ में आ गया तो हर बार तुम्हारा ऑब्जेक्ट क्या हो रहा है? मिरर के पास आते जा रहा है. और तुम देखोगे कि इमेज विल गो अवे फ्रॉम एफ. एक तो इमेज विल गो अवे फ्रॉम एफ और उसका साइज बढ़ते है. सबसे पहला साइज जो इमेज का है, जब ऑब्जेक्ट इंफिनिटी पे है तो वो साइज क्या बनता है? पॉइंट साइज बनता है. अब बाद में ये पॉइंट से बढ़ते जाएगा. अभी यहाँ पे समझ नहीं आ रहा है कि रियल इन्वर्टेड है कि नहीं, तो अब क्योंकि रियल है इसलिए हमने इन्वर्टेड मान लिया. लेकिन अभी सेकंड डायग्राम में तुमको क्लियर हो जाएगा कि वो रियल भी है और इन्वर्टेड भी. ठीक है, देखो. तो सेकंड ऑब्जेक्ट पोजीशन क्या होगी? ऑब्जेक्ट बियॉन्ड सी. ठीक है, ऑब्जेक्ट का डिस्टेंस हम हमेशा मिरर से पकड़ते हैं, इसलिए मिरर से जब इधर जाएंगे तो सी के बियॉन्ड आएगा. तुम बिफोर सी नहीं लिखोगे, क्या लिखोगे? बियॉन्ड सी. देखो अभी इसका डायग्राम कैसे बनेगा. पहले मिरर बन गया, फिर प्रिंसिपल एक्सिस बनाओ मिरर बनाने के बाद. ये सीक्वेंस है, पहले मिरर, फिर प्रिंसिपल एक्सिस, सी और फोकस मार्क करके छोड़ दो. लेवलिंग बाद में करना. पी लिख सकते हो क्योंकि रे अभी यहाँ पे नहीं है. देखो सब रियल इमेज कहाँ बन रहा है? फ्रंट ऑफ द मिरर में, क्योंकि रिफ्लेक्टेड लाइट कट कर.
जहाँ पर रियल इमेज बनेगा वो इमेज हमेशा इन्वर्टेड होगा.
हमेशा होगा. अभी इसमें क्लियर हो जाएगा इस डायग्राम में, यहाँ पे क्लियर नहीं होगा ना.
जहाँ पे वर्चुअल होगा वहाँ पे इरेक्ट होगा.
यस, ठीक है. तो सिक्स्थ डायग्राम जो इसका होगा, सिक्स्थ वाला, जब ऑब्जेक्ट तुम एफ और पी में रखोगे वो उसका वर्चुअल बनेगा. बहुत लॉजिकल है, उसमें कुछ रटना नहीं. देखो अभी तुम्हारा ऑब्जेक्ट कहाँ पे है? बियॉन्ड सी. अभी जब ऑब्जेक्ट इंफिनिटी पे था तो उसका साइज इतना बड़ा है हम उसको बना नहीं सकते, सन का साइज कैसे बना सकते हैं। लेकिन अब हमारा ऑब्जेक्ट कहाँ पे है, यहाँ पे लिया हमने, कुछ भी ऑब्जेक्ट लिया तो मान लो ऑब्जेक्ट हमारा कितना है ए बी, ये ऑब्जेक्ट का हाइट है, कहाँ पे रखा उसको बियॉन्ड सी। अब हमको क्या करना है, दो रेस चाहिए, कौन सा दो रे लेंगे, एक तो पैरेलल वाला ले लेंगे, ऑब्जेक्ट के हर पॉइंट से रेस निकल रही है, ठीक है ना, ऑब्जेक्ट के हर पॉइंट से रेस निकल रही है, तो एक हमने पैरेलल ले लिया, ठीक है, तो ये रे क्या होगी, रिफ्लेक्ट होगी एफ से आएगी, क्योंकि हमको पता है पैरेलल रे रहेगा तो रिफ्लेक्शन के बाद कहाँ जाएगा, एफ से आगे जाएगा, ठीक है, तो ये हमारा एफ था। दूसरा हमारा क्या है सी, तो हम एक रे सी से ले लेंगे, ये वाला रे इंसिडेंट अलोंग सी, ये देखो सी से जो जाएगा वो क्या हो जाएगा, ये सी से गया ऐसे, तो ये रिफ्लेक्ट होके वापस रिट्रेस करेगा, ठीक है, तो ये रिफ्लेक्टेड रे और ये रिफ्लेक्टेड रे कहाँ पे मिल रही है, यहाँ पे तुम्हारा क्या बनेगा, इमेज इसका ए का, ठीक है, तो वैसे ही अगर तुमने यहाँ से दो रेस पकड़ा तो उसकी इमेज यहाँ बनेगी, तो पूरे का पूरा ऑब्जेक्ट रिकंस्ट्रक्ट हो जाएगा। तो हम पूरे ऑब्जेक्ट के लिए नहीं, खाली फ्रंट टॉप का लेते हैं और उसको हम इसको ऐसे लिख देते हैं, ये ए डैश बी डैश। अब देखो ये रियल भी बन रहा है और इन्वर्टेड भी बन रहा है, दिख रहा है ये इन्वर्टेड, अभी लिख दो इमेज एट, इमेज कहाँ बनी है, बिटवीन सी एंड एफ,
इसमें सर ये
इमेज पोजीशन क्या है,
थर्ड
सिर्फ फर्स्ट, जो रे कन्वीनियंट, मैंने बोला था ना जो कन्वीनियंट हो कर लो, ऑब्जेक्ट पोजीशन के लिए जो कन्वीनियंट है, तुम अगर यहाँ से एफ पे लेते वो भी यहाँ से यहाँ जाता और यहीं आगे कट कर, पोजीशन वहीं बनेगी, चाहे तुम कोई भी रे ले लो, मिनिमम दो लेना है, तुम चारों लेके करो वहीं पे बनेगा ये इमेज जहां बना, समझ आ गया। तो इमेज बिटवीन सी एंड एफ, साइज क्या है, ऑब्जेक्ट इतना बड़ा है ये छोटा है, तो यहाँ पे साइज क्या लिखेंगे, डिमिनिश्ड, डिमिनिश्ड, तो ये इमेज की प्रॉपर्टी। तीसरी प्रॉपर्टी क्या है, रियल एंड इन्वर्टेड, बस यही हमको हर एक ऑब्जेक्ट के लिए करते जाना, सेम चीज रिपीट हो, ठीक है। सो रेस्ट विल टेक इन दी नेक्स्ट क्लास।